Hello and welcome. It is time once again to try to fix something, and today on the workbench we're going to be taking a look at a PS5 1215 model. This is the later model, CFI-1215A Blu-ray edition, and I think this is a no power, as a lot of them are. I've got it connected. I haven't hit any buttons on it yet. No eject. Okay, so no signs of life whatsoever, no beeps, nothing like that. Dead power supply or dead motherboard. That's pretty much our choices at this point. Let's get some covers off and see if it's been messed with before. Alright, outer cover's off, and well, doesn't appear to have been opened before, which is amazing because they're always opened. But I'm seeing screws everywhere and that security tape is still in place. That's good. Well, I have removed the power supply. We're going to see if we can check it here right quick like. Just see if that's our problem or not. Well, it is a problem. 4.5 volts coming out of that power supply. That's an odd one. Okay, so we do have a power supply problem. Okay, let's see if we can fix this power supply. I do have one. I do have a spare one, a 400 FR. Let's pop that in there and just confirm everything else is good. Alright, our spare supply is installed. I've got the Blu-ray sitting in there connected just in case it happens to be in the middle of an update or something, because it won't update without that Blu-ray drive. What else? Power. Let's see what she does. Oh, there's something in the drive. I think I heard a click. And my monitor decided to go to sleep just as I hit the power button. Blue light. Nothing yet. Oh, white light. Come on, give me a picture. There we go. Alright, so it looks like we just have a power supply problem. Low voltage. Should be an easy fix there. I think I've seen that issue before on these supplies. So let's get this inside and see if we can knock this one out relatively quickly. That looks promising. Excellent. Alright, here we are inside the workbench, ready to see what's going on with this PS5 power supply. And let me mention again, I don't recommend people do this. And by this I mean opening up your power supplies, because there are dangerous voltages inside, so please don't do that unless you're very well trained in how these things work and how to stay safe. So that's my rant. But the problem this was having is low voltage, and that sounds familiar to me before. You know, could be the old DAP53, since it's kind of responsible for a lot of things. It's the power factor corrector, it's the, you know, main DC-DC converter in the thing. But this particular problem, I want to say, has been a small MOSFET, part of the control circuitry. So I'm going to start there if I ever get this thing open. I hate to, you know, unnecessarily replace that DAP53. I mean, I will. These things are so frustrating. Finally, we're in. And the first thing I am going to do is discharge the main filter capacitors so I don't get bit and don't damage my meter or something. Okay, should be discharged and safe now. This could be the DAP53, but there is also a MOSFET over in here that has caused that before. I'm forgetting which one it was. One of these two, I think they are. Let's see. Let's get under the microscope. Too small for me to see. All right, let's take a look under the microscope. Maybe we'll take a look at this DAP53 first. Pin 1.70, that sounds about right. 2 is 0.579, that sounds right. 3 is 635, it's a little low. 4 is ground. 5 is 656. 6 is 648, that looks right. Not connected. 1.48, that looks right. That looks right. 1.12, 1.13. Perfect. That's a little low. Perfect. 620. Yeah, 697. 686. That looks pretty good. What about over here on these opto isolators? That looks fine. That's probably ground. Looks fine. Okay, that I've seen before. I don't think that's normal. 0.03. Let me get the shot on. This is going to be the cathode of what is this? IC51, and that is connected to something. I lost track of it. It may be this. Let's try to find that again. So where were we? Right here. Let's follow it around. So we go under this diode. Right here, I believe. Bottom trace right here. So it's a small left one here. Yeah, Q33. Marked K72. I don't recognize that part number. What do we measure? Yeah, that's that same reading. Yeah, this seems to be a very shorted part. See if I can figure out what Q33 is. I think it's a MOSFET of some type. And I think it is dead. All right, and here is our friend, Mr. K72. He is simply a 2N7002 made by Diodes Inc. So I do have some 2N7002s. We will change that out And these things, I've seen these go because in the circuit they are in, they are electrically very close to the front end where the AC input is. I think it's part of like an overvoltage sensing, either overvoltage or undervoltage for the AC input. Not entirely sure, but they're so close to the front end that spikes on the AC input line seem to pop them. Let me get that swapped out and let's see if that solves our problem. Alright, well, our tiny little MOSFET has been replaced. Let's see if we've done any good. I have my load connected, set for 6 amps. I'm monitoring the voltage across the filter cap. So I want to see what the boost voltage is for the power factor corrector when it's running. If it runs, let's give it some AC. We're trying. We're not quite there though. We are trying. Very strange behavior. Something else has gotten popped. Maybe the optical isolator is connected to? Not sure. Alright, well, I've been looking all over this board. Haven't found anything else. So here's the Q33 that I replaced. And it was definitely shorted. But I think we probably have also taken out our DAP53. So I think that's my next move. I've got one sitting here ready to go. Let's go ahead and get that swapped out and see if that solves our instability issues. Alright, well, our DAP53 has been swapped out. Has that solved our problem? I'm still watching the PFC boost voltage here, and I've got the load turned on back there. No, that boost voltage is getting really high. That cap's only rated at 450 volts. Something is off. Something is pushing that voltage bad high. All right, I have removed Q34, is it? Have to confirm that number. Or is it Q32? It's part of a shutdown circuit, and I've had it give problems before. you know, thought I'd give it a try. And it did not have the effect I wanted, as you can see. 4.5 volts we're putting out, but our boost voltage is not going crazy anymore, or not as much anyway. Focus. So yeah, that's not it. Keep going. All right, where are we now? Well, we have a strange problem, so I'm having to try a different method. And what I have done is I've broken out a working ADP400FR to make direct comparisons to. And I may have found something. If I can show you. All right, this is a working one over here on the right. Well, this is the non-working one. I've already got the ground wire hooked to the left one here. This is the broken one. If I go to, I'm going to make some comparisons around this DNP14 right here. And one of these pins doesn't look quite right compared to the other one. And it's hooked to this opto-isolator. Right there. I don't know if I can get on the leads. Let's see. Well, ground connection. Get my ground connection like it should be. Are we connected now? Yes. That end is grounded. The other end, you can see, starts off like 120 or 30 ohms and rises up slowly. All right. That's not really normal compared to this side. Let me get my ground lead over here. Make sure I'm connected. I am not. I hate this ground lead. It's 100 years old. Okay. Now we are grounded. If I touch that, we're grounded. Ish. Oh, come on. Alright, that looks like it's a good connection. If I go to that same pin here, that same op amp, this end is connected to ground. The upper side, though, I get 139 k ohms compared to like 130 ohms on the other side. And maybe it's coincidence, but if you remember, the first thing we replaced was Q33 here. And this is the only component that was definitely damaged. It was definitely shorted. And that component connects to this side over here of that same opto-oscillator. Now, is that a coincidence or is it related that I have a low resistance reading on this side? I think I'm going to replace this. This is an EL1019. I have them. I think what I'm going to do first, actually, I think I'm going to lift the lead and see if I still get that low resistance. I'll lift one of these pins. And if I still have it, then we may have a bad DNP14. It's probably game over because those don't seem to be available, at least not yet. So let me lift one of those pins and see what it looks like. All right, well, I did lift the pins, or a pin on this opto isolator, and the problem was still elsewhere. So I have lifted a capacitor on that same line. That's not it. I finally lifted pin 3 of the DNP14 and that low resistance went away. So it is definitely the DNP14 and those are not available. So unless I can figure something else out, that's going to be the end of the line for this power supply. I do have some spares I could just swap in there. I have one spare. It's sitting right here. But I've got some others I can fix up, I think. But yep, maybe the end of line for this one. Well, we're back out in the garage. The PS5 is fully reassembled and working great. I did have to install my spare ADP 400FR power supply though. Sadly, this supply will be dead until we can get our hands on the DNP 014 IC, which is not available right now. But I will hang on to it and I'll put a note on it saying that's what it's in need of. And I know this is the only spare 400FR supply I had that I just put in here, But fortunately, I just got in 3 more broken ADP 400FR supplies. So hopefully I can repair those and be looking for a video on that. And this will have 3 spares then, so it all works out. Well, anyway, I hope you enjoyed that one. Thought it was somewhat interesting, entertaining, educational. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.